Greetings to every one of you. So in this video we are going to discuss another very important concept from artificial intelligence, that is MINIMAX algorithm. This algorithm is mainly used in game theory. It is used in the games where two players can play. Games such as tic-tac-toe, chess, etc. It uses the techniques like backtracking and the recursion. This algorithm, as I said, it contains two players. One is maximum player and another is minimum player. So the max player chooses a highest value from the child nodes, and similarly the min player will choose the minimum value from the child nodes. As far the time complexity is concerned, it is order of b power d, where this b is number of branches and the d represent the depth level. The various steps of this algorithm are given here. First step, we have to create the game tree right from root to the terminal nodes. Apply the utility function on all the terminal nodes in order to find their values. So the algorithm will perform, it generates the game tree and it also generates the value for the terminal nodes. These are the different values that is calculated by the algorithm. This algorithm uses depth first search method. The procedure is used in this algorithm. It starts from the root node and it reaches to the terminal node, that is the end node. For example, the first time it go and seeks, it start the search only from the lower left node, that is H. Then it goes to the node D, then again I. Then after this, after completion of this, it goes to, that is B, then again E to, that is J. From J to E, then again E to K. It continues like this. After generating the leaves or the terminal nodes, the max node computes the maximum value and the minimum node computes the minimum value, because the root is indicated as the max. So two players are playing. One player, max player, is a maximizer and another player is min player, he is a minimizer. So player 1, he wants to maximize the chances of the success, and this minimum player minimize the chances of success of the opponent. So that is the idea of this minimax procedure. So min node computes the minimum value. So after reaching the root, the final optimal path is determined. Now let us see how this algorithm works with the help of this example. As I said, start from root node. So since it uses DFS, depth first search, so the first seek falls on the node H. So the value of the node H, it is 12, and that will be, that is backup to this node, that is D. As I said, this is the max node. So what will happen? This will check whether the next value, the next node, it is maximum or minimum. So the value 12, it is compared with the value of node I. So value of node I is 8. So 12 is greater than 8. So automatically this 12 will be retained here. Again this value will be, that is backup to its parent, that is node B. Now from B we follow this DFS. So the search starts from, that is the node J. So here the value of J, it is 15, and that will be, that is backup to its parent, that is E. Again 15 will be, that is compared with the next node, that is K, that is 19. So 15 and 19, if we compare, the 19 is the greater value. So 19 will be, that is become the value of this node. So no more, that is 15. Okay. So again we compare this value with the previous one, that is this is 12 and this is 19, but the node is, that is minimum node, so minimum player. So he will select only the minimum value. If you compare 12 with 19, 12 is the minimum, so 12 will be, that is retained as it is. This value again, that is backup to the root node, that is the parent. So 12 will be, that is backup to the root, that is 12, value of root is 12 now. Now again we start the search using the DFS. From the root we will reach C and F and then L. So that is take the value, that is L, and that will be, that is backup to this node F. Now again this value, that is the 6 will be, that is compared with the value of the node M, which is greater, that is 6 is greater. So 5 is lesser than 6, so automatically 6 will be, that is retained as it is. Okay. So again this value 6 will be, that is again backup to its parent, that is C. Now from C we will follow this DFS, reaching the node, that is N, which is 25, and this value will be, that is compared with the next node, that is 2. So we have to, that is consider only the maximum value. So this 2 will not be considered, and value of J is 25. And now we have to, that is compare these two, and if you compare these two again, that is we have to consider only the minimum value. So 6 is the minimum value, so this value will not be, that is considered here. And now here we have to, that is again we have to compare this with this value, that is 12 and that is 6. So we have to consider only the maximum value. So 12 is greater than 6, so the final value of this root, it is 12. So now if you find out the path for the maximum player, it is A to B, and that is B to D, and then D to, that is H. That is the path, and the final value for the root node is 12. Okay, final value for the root node is 12, and the optimal path, it is A, B, D and H. So as far the time complexity is concerned, I said it is order of B power D. So this B is nothing but number of branches, and D is the depth level. See, for example, if you have, that is 3 branches, and consider you have there is 2 depth value is 2, so it is nothing but that is 9. The time complexity is 9. So if it is a small game with a limited number of states, the time complexity maybe there is less. If you consider the game like chess, in which again this the number of states maybe there is large, very large. So again performing this searching in case of the games like chess, it is very vast one, very huge one. So in order to, that is reduce this time complexity and this number of state space, we can introduce a concept called alpha beta pruning, that we will discuss in our next video. Thank you. Keep watching.